Welcome to Unit 1, Lesson 8, Subtracting Fractions with Unlike Denominators. Our target is working on I can use equivalent fractions to add and subtract fractions. Huge target. You have to be able to make equivalent fractions. Today we'll be working on subtracting fractions with different denominators. Let's say we have the situation, Nina has 5/6 of a yard of fabric. She uses 2/3 of a yard of it to make a pillowcase. How much fabric does Nina have left? You have to pay attention to the fact that our whole is a yard of fabric. So our whole here is 1 yard. She has 5/6 of a yard. So when I draw my diagram, I know that she has 1/6, 2/6, 3/6, 4/6, 5/6 of a yard. Now, she's going to use 2/3 of a yard of it to make a pillowcase. She's not using 2/3 of what she has, she's using 2/3 of a yard. So how can we use a fraction bar above to solve this problem? Well, we need to take 2/3 of a yard from here, but our fraction bar is not partitioned into thirds. So we need to think of how can I partition this into thirds? I need to think about what am I going to do? How am I going to find what 2/3 is equal to in 6? So I'm going to think equivalent fraction to 2/3. Well, I know to make an equivalent fraction, I divide by 1 or multiply by 1 in the form of a fraction. Well, for 3 to become 6, it's going to be multiplied by 2. And I know by now that whatever I multiply my denominator by, I multiply my numerator by, because a fraction equivalent to 1 has the same numerator and denominator. 2 multiplied by 2 is 4/6. So 2/3 are equal to 4/6. So to subtract 2/3, I need to subtract 1/6, 2/6, 3/6, 4/6. And how much fabric does Nina have left? 1/6 of a yard. Let's take a look at another situation. George ate 3/8 of a pizza. Raphael ate 5/12 of the same size pizza. Who ate more? How much more did he eat? All right. Well, how much more did he eat? I know is a subtraction situation. But to subtract, I want to take my greater value and subtract the lesser value. When I want to know how much more something is, I start with my greater value and subtract my lesser value. So I need to figure out which is greater, 3/8 or 5/12. So first thing I look at, that's a 2, pretend it's a 2, guys. First thing I look at is my denominators. Do I have the same denominator? No. Numerators, do I have the same numerator? No. Then I'm going to use benchmarks. 3/8 I know is a little less than half. Half of 8 is 4. It's 1/8 less than half. 5/12 is less than half also. Half of 12 is 6. So this is 1/12. 12 is a larger number, so more pieces mean smaller pieces. So 5/12 is closer to a half. And 3/8 is further less than a half because it's a whole eighth less. So I know that 3/8 is less than 5/12. If I didn't know that, I'd have to say equivalent or use a common denominator. So whenever I'm finding a common denominator, my first question is one of my denominators 8 a factor of 12? And it's not. Nothing multiplied by 8 is 12. So the next thing I'm going to say is their only common factor 1? But it's not, because I know 8 and 12 both have 2 and 4 as common factors as well. So I don't need to go 8 multiplied by 12 is 96 as my common denominator. I can use a lower common denominator. So I think of my multiples of 8 and 12. Well, I know 8 multiplied by 2 is 16. 8 multiplied by 3 is 24. Wait. 12 multiplied by 2 is also 24. So I can use 24 as a common denominator. If I didn't know that 3/8 was less than 5/12, I could use that. If I multiply 8 by 3 to get 24, then I had to multiply my numerator because my pieces just got 3 times smaller. I need 3 times as many to be equal. So I have 9/24. Since my denominator became 24 by multiplying by 2, I have the pieces 2 times smaller. I need 2 times more pieces. 5 multiplied by 2 I know is 10. So, and I was right, 9/24 is 1/24 less than 10/24. Now, I didn't mind doing this to check because I need it for my subtraction anyway. I need common denominators. I'm not going to go 5/12 subtract 3/8. I'm going to write them with the common denominators. 10/24 subtract 9/24. And that subtraction then is really quite simple. I just take the numerator, 10, subtract numerator 9, and I have 1 left. The size pieces are still 24s. I subtract numerators, keep my denominator the same. Now, I have to answer the question, who ate more? So the person that ate 5/12 of a pizza ate more. So Raphael is the answer to the first question. And the answer to my second question, how much more did he eat? 1/24 of a pizza. So when I'm subtracting fractions, I want to compare first to see which one is greater, then get a common denominator if I don't already have one, subtract numerators, keep my denominator the same. Something I want to point out, George ate 3/8 of a pizza, Raphael ate 5/12 of a same size pizza. This problem says they ate the same size pizza, therefore their whole is the same. If George ate 3/8 of a large pizza and Raphael ate 3/12 of a medium pizza, we couldn't compare the fractions, could we? All right, in your book, starting on page 23, is lesson 8. I'm going to just take a look at our lesson 8. I'm going to take a look at these problems. There are more pages of subtraction problems too. Annie used 7/9 yards of ribbon in her dress. Jasmine used 5/6 yards of ribbon in her dress. Which girl used more ribbons? So I need to compare my two amounts. 7/9 compared to 5/6. So when I'm comparing, all right, I don't have a common denominator. I don't have common numerators. I have 7/9 is 2/9 from a whole. 5/6 is 1/6 from a whole. But 9s are a little smaller than 6, so I just don't know which is closer. So I need a common denominator. So first I look, is 6 a factor of 9? No. Nothing multiplied by 6 gives me 9. Is 1 the only common factor of 9 and 6? No. I know that 3 is a common factor of 6 and 9. 3 multiplied by 2 is 6. 3 multiplied by 3 is 9. So I do not need to go 9 multiplied by 6 is 54 and use 54 for my common denominator. I can think of their multiples. My multiples of 6 and 9, which ones do they have in common? Well, 6 multiplied by 6 or 6 multiplied by 1 is 6, not a multiple of 9. 6 multiplied by 2 is 12. Nothing multiplied by 9 is 12. 6 multiplied by 3 is 18. Bingo. I know that 9 multiplied by 2 is 18. So I'm going to use 2 as my multiplier here. To make 14/18. Wow, it's hard to draw this little. And I'm going to use 3 as my multiplier on this fraction, multiplying by 3/3 because that's equivalent to 1, and that's not going to change the value of my number. It's just going to make it so I have equal size pieces. 5 multiplied by 3 is 15. 6 multiplied by 3 is 18. Now, once I have common denominators, all I have to do is compare numerators. Having 14/18 is less than having 15/18. So, which girl used more ribbon? The girl that used 5/6 is Jasmine. Now, how much more? Take my greater one. My greater is this side, 15/18. Subtract my lesser, 14/18. And this really is mental math now, isn't it? If I had 15/18 and I subtract 14 of them, 15 subtract 14 of them, I would still have 1/18 left. Remember, 18ths, the denominator, is just a label. It's just telling me the size of my pieces. So 1/18. Mr. Sue and Mr. Franks are the same in the same book club. Mr. Sue is 5/7 of the way through this month's book. Mr. Franks is 3/5 of the way through the book. So our whole is the book. Who read more? So I need to compare Mr. Sue's 5/7 to Mr. Frank's 3/5. Do not have common denominators, do not have common numerators. 3/5 is a little more than half because half of 5 is 2.5, so 3 is a little bit more. 5/7 is a little more than half because half of 7 is 3.5. So I do not have common denominators, or I can't use benchmarks to figure out which is greater. 7, do they have, is 5 a multiple or a factor of 7? Nope, nothing times 5 is 7. Do they have a common factor other than 1? No, they don't. The only factors of 5 are 1 and 5. The only factors of 7 are 1 and 7. They don't. So I'm just going to use the other denominator, 5, as my multiplier here. And get 25 35ths. And on this fraction, I just use the other denominator, 7, as my multiplier to get 35ths. And that is a method that does always work. Just so you know, you can always do that. It's just not always efficient. Like the one before, it wouldn't have been efficient. Now it's easy to compare. Having 25 35ths is greater than having 21. So whoever had 5/7 is Mr. Sue. And then again, I think this should be mental math. 25 35ths subtract 21 35ths. If I have 25 of anything and I subtract 21 from them, I'm going to have 4 left. In this case, I have 4 what's left? I have 4 35ths. Last one I'm going to do for you, or with you. Rami ran half a mile. Will ran 3/8 of a mile. Who ran farther? Well, half a mile is equal to a half. 3/8 is less than half because half of 8 is 4. So 4/8 would be half. 3/8 is less than half. So I know right there, Rami ran further. Since I know Rami ran further, Rami is going to be the first one in my equation, and Will's will be the second. Now, that really didn't save me much time because as I look, I still need a common denominator. But what I do notice is I only have to change 1 because 2 is a factor of 8. All right? So I only have to change 1/2 into 8ths. So my multiplier is what times 2 equals 8, and that's 4. Now my numerator would be, what would be the numerator of a fraction if 4 is the denominator? Sorry about that. My numerator would be 4. 1 multiplied by 4 is 4. 2 multiplied by 4 is 8. Sorry that I laughed. I just realized I just said a minute ago half of 8 is 4. I know that 1/2 is equal to 4/8. I didn't not need to go through all that, did I? 4/8 subtract 3/8 now again is mental math. If I have 4 of anything and I subtract 3 of them, I have 1 of them left. And I said before, 1/8 or 3/8 is 1/8 from being a half. I knew that already. I really shouldn't have had to do any of that. All right, good luck with this. Watch it some more. Look through your student activity book. Go find some more videos if you need to, if you need some help with subtracting unlike fractions. Do notice this is not needing you to regroup. You're not subtracting mixed numbers. These are just fractions.